everybody. Okay, so in this video, we're just going to be looking at some exam questions involving Bernoulli trials. So this is a 2022 question. So 20 relay teams took part in a competition. For any particular team, the probability they drop the baton at some point during the competition is 0.1. Find the probability that at most 2 teams drop the baton during the competition. Give your answer to 4 cases. So there are 20 teams. We want to find out what's probably at most 2 of them drop the baton. So the probability of dropping the baton is 0.1. The probability of not dropping the baton is 0.9. 1 minus 0.1 is 0.9. There are 20 teams, right? And we're looking for at most 2. So we're looking for the probability no one drops the baton, the probability 1 person drops the baton, plus the probability 2 people drop the baton. So that would be 20 to 0. So out of my 20 teams, 0 of them drop the baton. 0.1 to the power of 0, because 0 people drop the baton. And 0.9 to the power of 20. Plus, probably 1 person drops the baton. 20 choose 1. 0.1 to the power of 1 times 0.9 to the power of 19. Then 2 people drop the baton. 20 choose 2. Times 0.1 power of 2, 0.9 to the power of 8. Right? And if you put that in our calculators now, so it's a big sum, right? If you put that in a calculator, so we get here 0.12518 plus 0.27017 plus 0.28518. And in total, that would be 0.6729. Right? So the probability at most 2 people will drop the baton, 67%. That's a good question. Let's look at the next one now. 2021. In a particular population, 15% of people are left-footed. A soccer team of 11 players, including 1 goalkeeper, is picked at random from the population. Find the probability there is exactly 1 left-footed person on the team. Give your answer correct 2, 3 decimal places. You want to find the probability there's exactly 1 left-footed person. So in my team of 11, there is 1 left-footed person. The probability of being left-footed is 15%. The probability of not being left-footed would be 0.85, because 1 minus 0.15 is 0.85. So 1 left-footed person, that means the rest of them, the other 10 are right-footed. Put that in a calculator, you get 0.325. Find the probability that less than 3 players on the team are left-footed. So less than 3 players on the team. So we want a probability that no one on the team is left-footed, plus the probability 1 person left-footed, plus the probability that 2 people are left-footed. So 11 choose 0 times 0.15 to the power of 0 times 0.85 to the power of 10. Nope, 11. Plus 11 choose 1 times 0.15 to the power of 1 times 0.85 to the power of 10 plus 11 choose 2 times 0.15 to the power of 2 times 0.85 to the power of 9. Add them up in our calculators, we get 0.78. That's the probability that less than 3 players on our team would left-footed. Right, so the last part here is the goalkeeper is left-footed. Find the probability that at least 8 players, at least 8 of the remaining players are right-footed. So I want to find a probability that 8 people are right-footed, find a probability that 9 people are right-footed, and a probability that the remaining 10 people are left-footed. So the goalkeeper is left-footed, so that means I'm only dealing with 10 people now. So 10 choose 8 times. Now, the probability of being right-footed is 0.85. Right? We're not dealing with left-footedness anymore. Plus 10 choose 9. 0.85 to the power of 9 times 0.15 to the power of 1. Plus 10 choose 10. Now, what's probably that the remaining 10 players are right-footed? 0.15 to the power of 0. This is equal to 0.197 plus 0.347 plus 0.276. And in total, that means 0.82. So 82% chance that at least 8 of my remaining players are right. Right, let's look now at this question from 2021. So, people with O negative blood type are called universal donors because their blood can be given to anyone else. In Ireland, approximately 8% of the population have O negative blood. At a blood donation clinic, 10 donors give blood, one after the other. Find the probability the 10th person is the third O negative donor. So that means the first 9 people, only 2 of them were O negative. So in 9 patients, 2 were O negative. The probability of being O negative is 0.08%, or say 0.08. We want 2 people to be that, and the remaining is 0.92. So the probability of not having O negative blood is 0.92. I want it to be 7. Right? That's the first 9, and then the 10th person comes along, right? And they are the third person with O negative blood. And this will be equal to 0.0103. Fine. The next part here. At a blood donation clinic, 5 donors give blood. Find the probability at least one of the 5 donates O negative blood. Give your answer correct to 4 decimal places. So we want to find at least one, right? So we could find a probability that 1 is O negative, 2 is O negative, 3 is O negative, 4 is O negative, right? But I just want to know, it's just easier for me to calculate 1 minus none of them are O negative, right? That'll be 1 minus, so out of the 5 people, we want none of them to be O negative. Then 0.08 power of 0 times 0.92 power of 5. That's going to be 1 minus 0.6591, which is equal to 0.3409. That is the probability that out of 5 people, right, at least one of them being O negative is 4%. Find the minimum number of blood donors required. So the probability that at least one of them is type O negative is greater than 0.97. So this is a really tricky one. So at least one of them is O negative. So what's the minimum number of people I have to bring in? So what is the smallest value of n, right? In order for my probability for at least one of them to be O negative to be greater than 97%. So be 1 minus the probability of 0. It's greater than 0.97. So that is 1 minus probability of all of them being negative will be 0.92 the power of n. Right? Because first person being O negative, 0.92. And the second person would be 0.92 times 0.92. The third person times it by 0.92 again. Fourth person times it by 0.92 again. And you do that for an unknown amount of patients, n. Now I want to solve what n is. So let me rearrange things first. So I have minus 0.92 to the power of n is greater than minus 0.03. And divide across by minus 1. 0.92 to the power of n is less than 0.03. So I divide it by minus sign, so I flip it. I flip my inequality. Now I have an unknown in the power. I have to use logs. Okay. So if I take the log of both sides, log of 0.92 to the power of n is less than log of 0.03. Right? I can use my rules of logs. I can bring this n outside here. So I can take this n and bring it outside. And I can say n is less than log 0.03 divided by log 0.92. Now, the tiny problem, right? 0.92, this is less than 1, right? And when we're dealing with logs of less than 1, they're going to be negative. So this log 0.92 is actually going to be negative. So that's going to flip my sign here. So n is greater than 42.05, I believe. What is it? 0.03 divided by log 0.92. That is going to be, 42.05. So what's the smallest number of patients it can be? Well, it can't be 42 because we have that point. You can't have like 0.5 of a patient. So n is going to be equal to 43. So in this case, we actually have to round up. So if I have 43 patients coming in, the probability that at least one of them is O negative is over 97%. Right. Let's do another question very similar to that one now. So we're doing with the 2017 question now. So Connor, when Connor rings Kira's house, the probability that Kira answers the phone is 1/5. Connor rings Kira's house once every day for 7 consecutive days. Stalker. Right. Find the probability that she will answer the phone on the 2nd, 4th, and 6th day, but not the others. So on the first day, she does not answer. On the second day, so she no answer, answers, no answer, answers, no answers, answers, no answers. So second day, 4th day, 6th day. So I know the order of things now. So I actually need to use Bernoulli trials for this one. So what's probably she won't answer? Well, the probability she will answer is 1/5. So the probability of no answer is 4/5. So it'll be 4/5 times 1/5 times 4/5 times 1/5 times 4/5 times 1/5 times 4/5. Right? We know the exact order of the days, so we actually don't need to do trials. And that will give me now 256 over 78125. Find the probability she'll answer the phone for the 4th time on the 7th day. So that means on the first 6 days, she answers 3 times. And on the 7th day, she answers for the 4th time. So the first 6 days, she answers 3 times. And on the 7th day here, she answers for the 4th time. So do this now. This will add up to 256 over 15625. Then here we go. Connor rings her house once every day for n days. Connor's a bit desperate, isn't he? Right. Write in terms of n the probability that Kira will answer the phone at least once. So at least once, that's 1 minus the probability that she does not answer at all. That'll be 1 minus the probability she doesn't answer is 4/5 for n consecutive days. So remember, that is just the first day she doesn't answer, second day she doesn't answer, times third day she doesn't answer, Do that for n days. Yeah? So that's it there in terms of n. Find the minimum value of n for which the probability that Kira answers the phone is greater than 99. That is 1 minus 4/5 power of n greater than 0.99 minus 4/5 n is greater than minus 0.01. 4/5 the power of n is less than 0.01 because I'm dividing across by -1. Flip the sign. Gotta use logs now. Log of, 4/5 is 0.8. I'm just making it a bit easier for myself. 0.8 to the power of n is less than 0.01. N log 0.8 is less than 0.01. N is less than 0.01 divided by, we're taking the log of both sides here. So it's log of 0.01, log of 0.01. That'd be log of 0.01 divided by the log of 0.8. 0.8 is a negative number, so I divide across there by a negative number, so I have to flip the sign, and that would be greater than 20.64 days. That means he has to ring for 21 days, right? 21 days for her for to have a 99% chance of answering. Right. Final question here. 2012. A certain basketball player scores 60% of the free throws shots she attempts. During a particular game, she gets 6 free throws. What assumptions must be made in order to regard this as a trial? So remember, we go back to my here, right? There are a fixed number of trials. The trials are independent. Each trial only has 2 outcomes, success and failure, and the probability of success and probability of failure do not change or are consistent for all trials. Fine. Based on assumptions, find correct the 3 decimal places. The probability she scores on exactly 4 of the 6 shots. So out of 6 of them, she scores 4. The probability of scoring is 60%, so 0.6. And then probability of not scoring is 0.4. That'll be power 4, power 2. Put that in a calculator. We shall get 0.311. And the last one here, she scores for the second time on the 5th shot. That means for the first 4 shots, she only scores once. So 0.6 to the power 1 because she only scores once. And then she misses 3 times. And times the probability she scores on the 4th shot, which is 0.6. So this is the first 4 days. This is the 5th day. Right? Do them up, you get 0.092. Right? So there are many, many, many more questions you can ask, but this is just a taster on some of the many questions you can ask on trials. I hope this video will some help to you guys. I'll catch you guys later. Bye.